Volanzis.com First Round. Q1. Introduce yourself and roles and responsibilities. Answer. I'm a passionate DevOps engineer dedicated to bridging the gap between development and operations. My day-to-day revolves around streamlining software delivery using a powerful AWS cloud arsenal and CI/CD pipelines. With tools like Git, Maven, GitHub, Docker, Ansible, Terraform, Artifactory, Kubernetes, and Grafana, I automate infrastructure provisioning, manage containerized deployments, and ensure application health and performance. Whether it's writing configuration scripts, monitoring dashboards, or collaborating with developers, I thrive in fast-paced environments where innovation and automation reign supreme. Here's a more detailed breakdown of my potential day-to-day tasks and activities. Warning. Review code changes in Git repositories like GitHub. Trigger CI/CD pipelines built with Maven and tools like Artifactory, automating build, test, and deployment processes. Write or maintain infrastructure as code scripts using Terraform or Ansible, managing AWS resources like EC2 instances, S3 buckets, and VPCs. Deploy containerized applications with Docker or orchestrate them using Kubernetes for scalability and resilience. Monitor application health and performance dashboards built with Grafana, identifying and resolving potential issues proactively. Afternoon. Collaborate with developers on improving CI/CD pipelines and automating manual tasks. Research and implement new DevOps tools and technologies to enhance efficiency and agility. Conduct code reviews and participate in technical discussions to ensure high-quality deployments. Automate security scans and vulnerability patching to maintain a secure cloud environment. Document processes and best practices to share knowledge and ensure smooth team collaboration. Evening. Stay up to date with the latest trends and advancements in the DevOps world. Contribute to open source projects and communities to share expertise and learn from others. Continuously seek opportunities to improve my skills and knowledge to become a more valuable DevOps engineer. Q2. What is your infrastructure in your project? Answer. Overview. 1. Source code repository. Host your project code in a version control system, e.g., Git. 2. CI/CD with Jenkins. Set up Jenkins and configure it to pull code from your repository. Create a declarative pipeline script in Jenkins for building, testing, and deploying your application. 3. Build with Maven. Use Maven to build your Java project and create a WAR file. 4. Artifact repository. Store the WAR file in an artifact repository, e.g. Nexus or Artifactory. 5. Infrastructure as code, IAC, with Terraform. Use Terraform to define infrastructure on AWS, e.g. VPC, subnets, security groups. Define ECS clusters for Docker container orchestration. 6. Docker containerization. Dockerize your application and create Docker images. 7. Container orchestration with Kubernetes. Deploy and manage containers using Kubernetes, either on AWS EKS or your own Kubernetes cluster. 8. Deployment with Ansible. Use Ansible playbooks to deploy your Docker containers on Kubernetes clusters. 9. AWS services for infrastructure. Utilize AWS services for various infrastructure components. Use AWS RDS for databases. Use AWS Elastic Load Balancer (ELB) for load balancing. Set up Amazon S3 for storage if needed. 10. Environment-specific configurations. Manage environment-specific configurations using Kubernetes config maps or secrets. 11. Deploy to test, UAT, and prod. Adjust your Jenkins pipeline to deploy to different environments based on triggers or manual approvals. CI/CD pipeline steps. 1. Check out code. Jenkins pulls code from the repository. 2. Build, Maven. Build the project using Maven. 3. Artifact management. Store the WAR file in an artifact repository. 4. Infrastructure provisioning, Terraform. Use Terraform to provision infrastructure on AWS. 5. Containerization, Docker. Dockerize the application. 6. Push to container registry. Push Docker images to a container registry, e.g., AWS ECR. 7. Deploy to Kubernetes, Ansible. Use Ansible playbooks to deploy containers to Kubernetes clusters. 8. Environment-specific configurations. Manage environment-specific configurations dynamically. 9. Testing. Conduct necessary tests, unit, integration, etc. 10. Deployment to environments. Deploy to test, UAT, or prod based on the pipeline configuration. 11. Monitoring and logging. Implement monitoring and logging for application health. 12. Rollback mechanism. Implement a rollback mechanism in case of deployment failures. Remember to secure your CI/CD pipeline, handle secrets securely, and regularly update and improve your infrastructure and deployment processes based on the evolving needs of your project. Adjust the tools and configurations based on your specific use case and requirements. Q3. How do you manage the infrastructure? How do you create infra manually or automatically? Answer. Infrastructure management involves the provisioning, configuration, and maintenance of computing resources, networks, and other components required to support the operation of software applications. There are generally two approaches to managing infrastructure, manual and automated. 1. Manual infrastructure management. Step-by-step configuration. In a manual setup, system administrators or DevOps engineers perform tasks like server provisioning, software installation, and configuration step by step. Manual configuration tools. This may involve using tools like SSH for remote access, configuration files for setting up software, and manual scripting for repetitive tasks. 2. Automated infrastructure management. Infrastructure as code, IAC. This is a key concept in automated infrastructure management. IAC involves using declarative or imperative code to define and manage infrastructure. Popular tools for this include Terraform, AWS CloudFormation, and Azure Resource Manager. Configuration management tools. tools like Ansible, Puppet, and Chef are used to automate the configuration and management of servers and applications. Container orchestration, platforms like Kubernetes automate the deployment, scaling, and management of containerized applications. Steps for automated infrastructure provisioning. Define infrastructure. Use code to define the desired state of your infrastructure. Version control. Store infrastructure code in version control systems, e.g., Git, for tracking changes. Continuous integration / continuous deployment. CI/CD. Integrate infrastructure code into your CI/CD pipeline to automate testing and deployment. Orchestration. Use tools to orchestrate the deployment and configuration of infrastructure components. Considerations. Scalability. Automated systems can easily scale to handle large infrastructures. Reproducibility. Infrastructure can be easily reproduced in different environments. Consistency. Automated systems ensure consistent configurations across environments. Efficiency. Automation reduces manual errors and accelerates the deployment process. The choice between manual and automated infrastructure management depends on factors like the scale of the infrastructure, the frequency of changes, and the need for consistency and reliability. Many organizations prefer automated approaches for their benefits in terms of speed, repeatability, and scalability. Q4. I have created an EC2 instance within a VPC, and that instance is attached or connected to RDS through Terraform script. How to write the script? Answer. This script assumes that you have already configured your AWS credentials and that Terraform is installed on your machine. Save the following code in a file with a .tf extension, e.g., main.tf. HCL. #main.tf. Provider AWS. Region equals us east 1 #. Specify your desired AWS region. #create VPC. Resource AWS_VPC my_VPC. sid_block equals 10.0.0.0/16. Enable_DNS_support equals true. Enable_DNS_hostnames equals true. Tags equals. Name equals myVPC. #create subnet. Resource AWS_subnet my_subnet. VPC_ID equals AWS_VPC.my_VPC.ID. sid_block equals 10.0.1.0/24. Availability_zone equals us east 1 #. Specify your desired availability zone. Map_public_IP_on_launch equals true. Tags equals. Name equals mySubnet. #create security group. Resource AWS_security_group my_security_group. VPC_ID equals AWS_VPC.my_VPC.ID. Egress. From_port equals 0. To_port equals 0. Protocol equals -1. sid_blocks equals 0.0.0.0/0. Ingress. From_port equals 22. To underscore port equals 22. Protocol equals TCP. Sig underscore blocks equals 0.0.0.0/0. Hashtag add additional rules as needed. Hashtag create RDS instance. Resource AWS underscore DB underscore instance my underscore DB underscore instance. Identifier equals mid instance. Engine equals MySQL. Instance underscore class equals db.t2.micro. Allocated underscore storage equals 20. Storage underscore type equals GP2. Username equals admin. Password equals your password. Publicly underscore accessible equals false. Skip underscore final underscore snapshot equals true. Multi underscore AZ equals false. Hashtag create EC2 instance. Resource AWS underscore instance my underscore EC2 underscore instance. AMI equals AMI XXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXX underscore type equals t2.micro. Key underscore name equals your key pair name. VPC underscore security underscore group underscore IDs equals AWS underscore security underscore group dot my underscore security underscore group dot ID. Subnet underscore ID equals AWS underscore subnet dot my underscore subnet dot ID. Tags equals name equals my EC2 instance. Hashtag add other EC2 instance configuration is needed. Hashtag output the RDS endpoint for reference. Output RDS underscore endpoint. Value equals AWS underscore DB underscore instance dot my underscore DB underscore instance dot endpoint. Please note the following. 1. Update the region in the provider block and the availability underscore zone in the AWS underscore subnet block according to your requirements. 2. Replace the placeholder values for AMI XXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXX commands. 3. Specify your desired key pair name and the key_name attribute. 4. Ensure that you replace your password in the AWS_DB_ instance block with a strong and secure password for your RDS instance. 5. Customize the security group rules and other parameters based on your specific requirements. After saving the file, run the following commands in the same directory: bash, terraform init, terraform apply. This will initialize Terraform and apply the configuration, creating the specified resources in your AWS account. Review the changes carefully before confirming the apply. Q5. Do you have any work experience in Kubernetes? Can you define it? Answer: Kubernetes. Kubernetes, often abbreviated as Kubernetes, is an open-source container orchestration platform designed to automate the deployment, scaling, and management of containerized applications. Developed by Google and later released as an open-source project, Kubernetes provides a robust and extensible platform for deploying and managing containerized applications in a clustered environment. Key concepts. 1. Container orchestration. Kubernetes automates the deployment, scaling, and management of containerized applications, abstracting away the complexities of manual container deployment. 2. Cluster. A Kubernetes cluster consists of a set of nodes, physical or virtual machines, that host containerized applications. It includes a master node and one or more worker nodes. 3. Pods. The smallest deployable units in Kubernetes are pods, which are logical groups of one or more containers that share the same network namespace and storage. Containers within a pod are deployed together and share resources. 4. Services. Kubernetes services provide a stable endpoint to expose a set of pods. Services enable communication and discovery between different parts of an application. 5. Replication controller/replica set. These components ensure that a specified number of pod replicas are running at all times, helping with application scaling and fault tolerance. 6. Deployments. Deployments are a higher-level abstraction that allows you to declaratively manage applications. They provide features like rolling updates and rollbacks. 7. Config maps and secrets. Config maps and secrets allow you to decouple configuration artifacts from the container images, making it easier to manage configurations and sensitive data. 8. Namespaces. Namespaces provide a way to partition resources within a cluster, allowing multiple teams or projects to share the same cluster without interfering with each other. 9. Kubelet and kubeproxy. Kubelet is an agent running on each node, responsible for managing containers and reporting their status to the control plane. Kubeproxy handles network proxy and load balancing. 10. Persistent volumes and persistent volume claims. These concepts enable the decoupling of storage from individual pods, allowing data to persist beyond the lifecycle of a pod. 11. Container registries. Kubernetes integrates with container registries, e.g., Docker Hub, Google Container Registry, to pull container images for deployment. Kubernetes simplifies the deployment and scaling of containerized applications, making it a popular choice for container orchestration in both development and production environments. It provides a rich set of features for managing containerized workloads and ensures high availability and reliability. Q6. Can you define kubelet? Answer. The kubelet is a service agent that controls and maintains a set of pods by watching for pod specs through the Kubernetes API server. It preserves the pod lifecycle by ensuring that a given set of containers are all running as they should. The kubelet runs on each node and enables the communication between the master and slave nodes. Q7. What is the EBS volume? Answer. Elastic Block Store (EBS) is a block storage service based in the AWS cloud. EBS stores huge amounts of data in blocks, which work like hard drives, called volumes. You can use it to store any type of data, including file systems, transactional data, NoSQL and relational databases, backup instances, containers, and applications. Q8. What is Kubernetes API server? Answer. Kubi API server, for all communications. This API server interacts directly with the user, i.ewe apply.yml or JSON manifest to Kuba App Observer. This Kuba app observer is meant to scale automatically as per load. Kuba API server is the front end of the control plane. Q9. What is etcd? Answer. Ect. It stores metadata and status of the cluster. Ect is consistent and high available store, key value store. Source of touch for cluster state, info about state of cluster. Ect has following features. Fully replicated, the entire state is available on every node in the cluster. B secure, implements automatic TLS with optional client certificate authentication. C fast, benchmarked at 10,000 writes per second. Q10. What are pods in Kubernetes? Answer. Pod. Smallest unit in Kubernetes. Pod is a group of one or more containers that are deployed together on the same host. A cluster is a group of nodes. A cluster has at least one worker node and master node. In Kubernetes, the control unit is the pod, not containers. It consists of one or more tightly coupled containers. Pod runs on node which is controlled by master. Kubernetes only knows about pods, does not know about individual container. Cannot start containers without a pod. One pod usually contains one container. Q11. I have one pod and one container running one application. I want to create another container so I can create in the same pod or another pod. Is it the same? Why and how to create a container inside the same pod? Answer. In Kubernetes, a pod is the smallest deployable unit and represents a single instance of a running process in a cluster. Pods can have one or more containers running inside them. The decision to have multiple containers in the same pod or in different pods depends on the requirements of your application and the design considerations. Here are some considerations for deciding whether to have multiple containers in the same pod. Same pod. 1. Shared resources. Containers in the same pod share the same network namespace and can communicate with each other using localhost. This makes it easier for them to share data via inter-process communication. 2. Shared storage. Containers in the same pod can share the same volumes, making it convenient for them to share data. 3. Atomic deployment. Containers in the same pod are scheduled and deployed atomically, meaning they are scheduled and started together on the same node. Different pods. 1. Isolation. If you need a higher degree of isolation between different parts of your application, you might want to run them in separate pods. 2. Scaling. If you want to scale different parts of your application independently, it might make sense to have them in separate pods. How to create multiple containers in the same pod. To create multiple containers in the same pod, you would define them in the same pod specification. Here's a simple example of a YAML configuration for a pod with 2 containers. YAML. API version v1. Kind pod. Metadata. Name mypod. Spec. Containers. Name, container1. Image, image1 tag. Ports. Container port, 80. Name, container2. Image, image2 tag. Ports. Container port 8080. In this example, the pod named mypod has two containers named container1 and container2. Both containers are defined in the same pod specification and will be scheduled together on the same node. Remember that while using multiple containers in the same pod can be beneficial in certain scenarios, it also introduces tighter coupling between the containers, and you should carefully consider the implications for your specific use case. Q12. What is the namespace in Kubernetes? Answer. In Kubernetes, a namespace is a way to divide cluster resources between multiple users, or projects, within the same cluster. It provides a scope for names, meaning that names of resources must be unique within a namespace, but not necessarily across namespaces. Here are some key points about Kubernetes namespaces. 1. Isolation. Namespaces provide a level of isolation for resources within a cluster. Different teams or projects can use namespaces to organize and isolate their resources. 2. Resource scoping. Resources such as pods, services, and persistent volumes exist within a namespace. This allows for the creation of resources with the same names in different namespaces without conflicts. 3. Default namespace. If you don't explicitly specify a namespace when deploying resources, they are created in the default namespace. The default namespace is where resources exist if a namespace is not specified. 4. Namespace switching. Users can switch between namespaces, allowing them to work on resources within a specific namespace without affecting resources in other namespaces. 5. Resource quotas. Namespaces can be used to set resource quotas, which limit the amount of resources, CPU, memory, storage, etc., that can be consumed by the resources within that namespace. 6. Multi-tenancy. Namespaces support a multi-tenancy model, allowing different teams or users to share the same cluster while maintaining separation and avoiding naming conflicts. Examples. Create a namespace. YAML. API version v1. Kind namespace. Metadata. Name namespace. Deploying resources in a namespace. YAML. API version v1. Kind pod. Metadata. Name mypod. Namespace namespace. Spec. Containers. Name myContainer. Image myImage tag. Switching namespace. Bash. kubectl config set context current namespace equals mynamespace. Namespaces are a fundamental concept in Kubernetes and are useful for organizing, managing, and isolating resources in a cluster. They play a crucial role in supporting multi-tenancy and resource management in complex Kubernetes environments. Q13. I have a namespace inside. I have one pod and one container and one application is getting overloaded, so shall I create a container in the same pod or another pod? How to scale up? If the same pod, then how? Answer. Scaling an application in Kubernetes can be achieved by adjusting the number of replicas of a deployment or by horizontally scaling the pods. Whether you add more containers to the same pod or create additional pods depends on the specific requirements and architecture of your application. Scaling within the same pod. Pros. 1. Shared network namespace. Containers within the same pod share the same network namespace, making it easier for them to communicate with each other using localhost. 2. Shared storage. Containers in the same pod can share the same volumes, allowing for easier data sharing. Cons. 1. Tight coupling. Containers within the same pod are scheduled together and share the same lifecycle. This can result in tighter coupling, and if one container fails, it affects the entire pod. 2. Limited isolation. Containers within the same pod have a higher level of visibility and access to each other, which may not be desirable in some scenarios. How to scale within the same pod. If you decide to scale within the same pod, you can do so by updating the pod's definition to include additional containers. Here's a simplified example. YAML. API version v1. Kind pod. Metadata. Name mypod. Namespace namespace. Spec. Containers. Name container1. Image image1 tag. Ports. Container port 80. Name container2. Image image2 tag. Ports. Container port 8080. In this example, I've added a second container named container2 to the pod mypod. You can repeat this process to add more containers as needed. Scaling with additional pods. Pros. 1. Isolation. Different pods provide a higher level of isolation. If one pod fails, it does not affect others. 2. Independent scaling. Each pod can be independently scaled, allowing you to allocate resources based on specific container requirements. Cons. 1. Communication overhead. Communication between pods usually involves network communication, which may introduce some overhead compared to containers within the same pod. 2. Resource duplication. Resources such as volumes may need to be duplicated across multiple pods if they need to be shared. How to scale with additional pods. If you decide to scale with additional pods, you typically work with deployments or replica sets. Here's a simplified example. YAML. API version app/v1. Kind deployment. Metadata. Name myDeployment. Namespace namespace. Spec. Replicas 3 hashtags set the desired number of replicas. Selector. Match labels. App myapp. Template. Metadata. Labels. App myapp. Spec. Containers. Name myContainer. Image myImage tag. Ports. Container port 80. In this example, the deployment myDeployment is configured to create and manage 3 replicas of the pod template. Adjust the replicas field to the desired number. Choose the approach that best fits your application's requirements, taking into account factors such as communication needs, resource sharing, and isolation. Q14. Why shall I do the same pod? Answer. Running multiple containers in the same pod in Kubernetes can be beneficial in certain scenarios. Here are some reasons why you might choose to co-locate containers within the same pod. 1. Shared network namespace. Containers in the same pod share the same network namespace. This means they can communicate with each other using localhost and can easily share data through inter-process communication. 2. Shared storage volumes. Containers in the same pod can share the same volumes. This makes it convenient for them to exchange and persist data. 3. Atomic deployment. Containers within the same pod are scheduled and deployed atomically. They are started and stopped together on the same node. This can be important for applications with tightly coupled components. 4. Performance optimization. Co-locating containers can reduce the latency of communication between them since they are running on the same host and can communicate through in-memory mechanisms. 5. Simplified configuration. Managing configurations for containers within the same pod is simplified as they can share environment variables, configuration files, etc. 6. Single IP address. All containers within a pod share the same IP address. This can be advantageous for certain applications that rely on fixed IP addresses. 7. Resource sharing. Containers in the same pod share the same set of resources, CPU, memory, etc. This can be useful for applications where resource requirements are highly interdependent. 8. Microservices communication. For microservices architectures, co-locating containers in the same pod may be suitable for closely related microservices that need low latency communication. Example use cases: web server and sidecar. Running a web server in one container and a sidecar container that handles logging or monitoring in the same pod. Database and initialization. Running a database server in one container and a container responsible for database initialization or setup in the same pod. Application and proxy. Running the main application in one container and a proxy or load balancer in another container in the same pod. While co-locating containers in the same pod offers advantages, it's essential to carefully consider the architecture and requirements of your application. It introduces tighter coupling between containers, and if one container fails, it affects the entire pod. Evaluate whether the benefits of co-location align with your application's needs and whether the trade-offs are acceptable for your use case. Q15. Let's say the namespace name is Nashit inside the pod name of the Nashit pod. I want to SSH into the pod. What command do I use? Answer. To SSH into a specific pod in a Kubernetes cluster, you can use the kubectl exec command. Here's an example command assuming the namespace is Nashit and the pod is named nashitpod. Bash kubectl execit and nashit nashitpod/bin/bash. Explanation of the flags used. It allocates a terminal for interactive use. And noshit specifies the namespace where the pod is located. Nashitpod specifies the name of the pod you want to access. /bin/bash specifies the command to be executed inside the pod. In this case, it starts an interactive bash shell. Make sure to replace noshit and nashitpod with your actual namespace and pod names. Note, for this command to work, the pod must have a container with a shell, like bash, installed. If your container is using a different shell, adjust the command accordingly. Additionally, you need appropriate permissions to execute the kubectl exec command in the specified namespace. Q16. Why do we use bin/bash? Why not SSH? Answer. The reason for using /bin/bash instead of SSH when executing commands inside a Kubernetes pod using kubectl exec is based on the nature of the container and the tools available inside the container. Here's the explanation. 1. Pods and containers. In Kubernetes, a pod can have one or more containers, and each container runs a specific process or set of processes. When you use kubectl exec, you're executing a command directly within the container's context, not on the host machine. 2. Shell inside the container. The /bin/bash command is often used as it starts an interactive bash shell inside the container. This is useful for troubleshooting, exploring the container environment, and running commands interactively. 3. SSH versus bash. While you can install an SSH server inside a container and use SSH to connect to it, it's less common in the context of Kubernetes. Containers are designed to run a single process, and for debugging or interactive access, a shell is often preferred. 4. Minimal container images. Many container images used in Kubernetes are designed to be minimal and focused on a specific task. They may not include an SSH server by default to minimize the size of the image and reduce potential security risks. 5. Security implications. Running an SSH server inside a container introduces additional complexities and security considerations. Containers are typically designed to be lightweight and isolated, and adding an SSH server might go against the best practices for containerization. That said, if your container image includes an SSH server, you can use SSH to connect to it, but it's essential to consider the security implications and whether it aligns with the design principles of containerized applications. Using /bin/bash is a common and straightforward approach for interactive access and troubleshooting within a containerized environment. Q17. What is it? Answer. The adoption in the kubectl exec command stands for interactive and TTY, teletype. It is used to allocate an interactive terminal, TTY, for the executed command inside the container. Let's break down what each part means. 1. Interactive. The I flag allows you to interact with the container's process. It provides an open channel for input, allowing you to interactively run commands inside the container. 2. TTY. The T flag allocates a pseudo TTY, which simulates a terminal. This is necessary for running interactive commands like a shell, /bin/bash, inside the container, as a TTY is typically required for interactive terminal sessions. When you use both INT together as it, you enable interactive mode with a TTY, making it suitable for running commands that expect user input and produce output as if they were run in a terminal. Here's an example of how the flags are used with kubectl exec. Bash. kubectl exec at podname /bin/bash. In this example, it is used to start an interactive bash shell /bin/bash inside the specified Kubernetes pod. It allows you to enter commands interactively as if you were using a local terminal. Remember that the flags are commonly used when debugging, troubleshooting, or exploring the environment inside a container. It's particularly useful when you need to run commands interactively or troubleshoot issues within a running container. Q18. I want to see the number of running containers in pod? Answer. To see the number of running containers within a pod in Kubernetes, you can use the kubectl get pod command along with the output option to specify a custom output format. Specifically, you can use the JSON-path query to extract the information you need. Here's an example command. Bash. kubectl get pod podname o equals JSON-path equals range.spec.containers *name \n and wcl. Replace pod name with the actual name of your pod. Explanation of the command. kubectl get pod podname retrieves information about the specified pod. O equals JSON-path equals range.spec.containers *name \n and uses JSON-path to extract the names of all containers within the pod, separated by newline characters. WCL counts the number of lines, which corresponds to the number of containers. This command provides a count of the running containers within the specified pod. If you have multiple pods and want to check them all, you can use kubectl get pods and loop through the pod names accordingly. Q19. How am I able to see configuration of deployment in Kubernetes? Answer. You can view the configuration of a deployment in Kubernetes using the kubectl get command with the appropriate resource type. To see the configuration details of a deployment, you can use the following command. Bash. kubectl get deployment name o YAML. Replace deployment name with the actual name of your deployment. This command retrieves the YAML representation of the specified deployment, displaying details such as labels, replicas, selector, strategy, containers, and more. If you want to view the configuration of all deployments in a namespace, you can use bash kubectl get deployments o YAML. This command retrieves the YAML representation of all deployments in the specified namespace. Additionally, you can use kubectl describe to get more detailed information, including the current status, events, and conditions. Bash kubectl describe deployment name. Again, replace deployment name with the actual name of your deployment. These commands will help you inspect and understand the configuration settings of your Kubernetes deployments. Q20. I want to see the description of the deployment in Kubernetes through command? Answer. To see a detailed description of a deployment in Kubernetes, you can use the kubectl describe command. Here's the command to describe a deployment. Bash kubectl describe deployment name. Replace deployment name with the actual name of your deployment. This command provides a detailed description of the specified deployment, including information about the deployment's configuration, current status, events, and conditions. The output will show you details such as the number of replicas, strategy, selectors, and more. For example, bash kubectl describe deployment my deployment. This will give you a detailed breakdown of the specified deployment named my deployment. If you want to see the description of all deployments in a namespace, you can use bash kubectl describe deployments and namespace. Replace namespace with the actual name of your namespace. This command will provide detailed information about all deployments within the specified namespace. Q21. How do you create a deployment using command? Answer. To create a deployment in Kubernetes using the command line, you can use the kubectl create deployment command. Here's the basic syntax. Bash kubectl create deployment name image equals container image. Replace deployment name with the desired name for your deployment and container image with the container image you want to use. For example, to create a deployment named my deployment using the jenkins image from Docker Hub, you would use bash kubectl create deployment my deployment image equals jenkins. This creates a deployment with a single replica by default. If you want to customize the number of replicas, you can use the replicas flag. Bash kubectl create deployment my deployment image equals jenkins replicas equals 3. This creates a deployment with 3 replicas. After creating the deployment, you can check its status using bash kubectl get deployments. And you can describe the deployment to see more details. Bash kubectl describe deployment my deployment. Feel free to adjust the deployment name, container image, and other parameters based on your specific requirements. The examples provided use the jenkins image for illustration purposes. Q22. What is the difference between apply and create commands in Kubernetes? Answer. In Kubernetes, both the kubectl apply and kubectl create commands are used to create or update resources, but they have different behaviors and use cases. Kubectl create. 1. Purpose. The kubectl create command is primarily used for creating new resources. It's suitable for cases where you want to create a resource and don't need to manage changes to that resource over time. 2. Behavior. If the resource already exists, kubectl create will return an error. It does not support updates to existing resources. 3. Usage. Example of creating a deployment. Bash kubectl create deployment my deployment image equals jenkins. Kubectl apply. 1. Purpose. The kubectl apply command is used to create or update resources. It's suitable for both creating new resources and updating existing ones. It uses a declarative approach where you provide a YAML or JSON file describing the desired state of the resource. 2. Behavior. If the resource already exists, kubectl apply will update it based on the new configuration provided. It's useful for managing changes to resources over time. 3. Usage. Example of applying a deployment configuration. Bash. kubectl apply fdeployment.yaml. 4. Declarative approach. kubectl apply is often favored for a declarative approach to managing resources. You define the desired state of your resources in a YAML or JSON file, and kubectl apply ensures that the actual state matches the desired state. When to use each. kubectl create. Use kubectl create when you only need to create new resources and you don't anticipate making frequent updates to those resources. kubectl apply. Use kubectl apply when you want a more flexible and declarative approach for creating and updating resources. It's particularly useful in scenarios where you need to manage changes to resources over time, such as updating configurations or scaling deployments. In summary, kubectl create is more focused on resource creation, while kubectl apply is designed for a declarative and flexible approach to managing resources, allowing for updates and changes to be applied over time. Q23. What kind of architecture in Jenkins? Answer. Jenkins is a highly versatile web server, reverse proxy server, and load balancer that is known for its high performance, scalability, and flexibility. The architecture of Jenkins is event-driven and follows a modular design. Here are some key aspects of Jenkins's architecture. 1. Event-driven architecture. Jenkins uses an event-driven architecture that allows it to handle a large number of concurrent connections efficiently. It is designed to handle many connections simultaneously without the need for threads or processes per connection. Instead, it uses an event loop to manage multiple connections asynchronously. 2. Master worker model. Jenkins follows a master worker model. The master process is responsible for managing worker processes. The worker processes handle the actual client requests. This model provides better scalability by allowing multiple worker processes to run in parallel. 3. Configuration file. Jenkins's configuration is typically defined in a configuration file, often named jenkins.conf. The configuration file specifies various settings, including server configurations, locations, and proxy settings. The modular and hierarchical nature of the configuration file allows for flexibility and ease of management. 4. Modules. Jenkins's functionality is extended through the use of modules. There are core modules that provide essential features, and additional modules can be dynamically added to extend Jenkins's capabilities. Examples of modules include the HTTP module for handling web traffic, the SSL module for handling secure connections, and the upstream module for load balancing. 5. HTTP and reverse proxy. Jenkins is commonly used as a web server to serve static content and as a reverse proxy to forward requests to other servers, e.g., application servers. It excels at efficiently serving static files and can also cache content to improve performance. 6. Load balancing. Jenkins can act as a load balancer, distributing incoming requests among multiple back-end servers. This is particularly useful for achieving high availability and distributing the load across server nodes. 7. SSL/TLS termination. Jenkins can handle SSL/TLS termination, offloading the task of encrypting and decrypting data from the back-end servers. This helps improve the overall performance of the system. 8. Community and open source. Jenkins is open source and has a vibrant community. Its modular design, performance, and flexibility have contributed to its popularity in various use cases, ranging from serving static content to acting as a load balancer for dynamic web applications. Jenkins's architecture, with its focus on performance, scalability, and flexibility, makes it a popular choice for serving web content and managing web traffic in a wide range of scenarios. Q24. What is upstream in Jenkins? Answer. In Jenkins, the term upstream refers to a group of back-end servers that can process requests forwarded by Jenkins. Upstream servers are typically used in the context of load balancing, where Jenkins distributes incoming requests among multiple back-end servers to achieve better performance, high availability, and efficient resource utilization. Key points about upstream in Jenkins. 1. Load balancing. The primary purpose of defining an upstream block in Jenkins configuration is to enable load balancing. Jenkins can distribute client requests among the servers defined in the upstream block, helping to balance the load and prevent any single server from becoming a bottleneck. 2. Configuration syntax. The configuration syntax for defining an upstream block looks like this. Jenkins. Upstream backend. Server backend d1.example.com. Server backend d2.example.com. Server backend d3.example.com. In this example, backend is the name of the upstream group, and it includes 3 backend servers. 3. Server selection algorithms. Jenkins supports various load balancing algorithms for distributing requests among upstream servers. Common algorithms include round-robin, least connections, and IP hash. The upstream block allows you to specify the desired load balancing algorithm. For example, Jenkins. Upstream backend. Least_con. Server backend d1.example.com. Server backend d2.example.com. Server backend d3.example.com. 4. Backend servers. The server directive within the upstream block defines the IP address or domain name of a backend server and an optional port number. Jenkins will distribute client requests among these servers based on the configured load balancing algorithm. 5. Failover and high availability. Upstream configurations can include backup servers that are only used when the primary servers are unavailable. This supports failover and enhances the high availability of the application. 6. Dynamic backend discovery. In some setups, the list of backend servers may not be static, and Jenkins can dynamically discover the backend servers using the DNS resolver. This allows for more flexible and automated configurations. Example of using an upstream block with load balancing. Jinx. HTTP. Upstream backend. Server backend d1.example.com. Server backend d2.example.com. Server backend d3.example.com. Server. Listen 80. Location / proxy _ pass http / backend. In this example, Jinx listens on port 80 and forwards requests to the backend servers defined in the backend upstream block using the proxy _ pass directive. The load will be balanced among the specified backend servers. Q25. I want to create a user in Linux through command? Answer. To create a user in Linux using the command line, you can use the useradd command. Here's a basic example. Bash. Sudo useradd ms/bin/bash username. Replace username with the desired username for the new user. Explanation of the options used. M. Creates the user's home directory if it does not exist. S/bin/bash sets the user's login shell to bash. You can replace this with the desired shell, e.g., /bin/zsh. After creating the user, you should set a password for the new user using the password command. Bash. Sudo password username. Replace username with the username you created. Follow the prompts to set the password. If you want to add the new user to a specific group, you can use the usermod command. Bash. Sudo usermod ag group name username. Replace group name with the name of the group, and username with the username you created. Make sure to adjust the commands based on your specific requirements and security policies. Additionally, consider using tools like adduser or useradd with additional options for more advanced user creation and configuration. The adduser command is a higher-level interface to useradd and is more user-friendly. Q26. I want to give user privileges? Answer. To give user privileges in Linux, you typically leverage the sudo command or modify the user's group memberships. Here are a few common scenarios. 1. Adding a user to the sudo group. The sudo command allows a permitted user to execute a command as the superuser or another user, as specified in the sudoers file. To grant sudo privileges to a user. Bash. Sudo usermod ag sudo username. Replace username with the actual username. After running this command, the user will be able to use sudo to execute commands with superuser privileges. 2. Granting specific privileges in sudoers file. 1. Edit the sudoers file using the vsudo command. Bash. Sudo vsudo. 2. Add a line to grant specific privileges to the user. For example, to allow the user to run any command as any user with sudo. Text. Username all sadface all. Adjust the privileges based on your specific requirements. 3. Adding a user to a specific group. If you want to grant specific privileges associated with a group, add the user to that group using usermod. Bash. sudo usermod ag groupname username. Replace groupname with the name of the group and username with the actual username. 4. File permissions. Granting user privileges can also involve adjusting file and directory permissions. Use the chown and chmod commands to change ownership and permissions. Bash. Sudo chown username groupname /path/ to /file_or directory. Sudo chmod permissions /path/ to /file_or directory. Replace username, groupname, permissions, and /path/ to /file_or directory with appropriate values. Important notes. Be cautious when granting sudo privileges, and only give the necessary permissions to users. Editing the sudoers file should be done with the sudo to avoid syntax errors. Always follow the principle of least privilege. Grant only the minimum privileges needed for users to perform their tasks. Remember to adjust these commands based on your specific use case and security requirements. Q27. I want to give directory ownership in Linux? Answer. To change the ownership of a directory in Linux, you can use the chown command. Here's the basic syntax. Bash. Sudo chown owner group directory _path. Owner, the new owner of the directory. Group, the new group for the directory. Directory _path, the path to the directory whose ownership you want to change. Examples. 1. Change the owner and group of a directory. Bash. Sudo chown john user /path/ to /directory. This command changes the owner of the directory to John and the group to users. 2. Change only the owner of a directory. Bash. Sudo chown jane /path/ to /directory. This command changes only the owner of the directory to Jane and keeps the group unchanged. 3. Change only the group of a directory. Bash. Sudo chown admin /path/ to /directory. This command changes only the group of the directory to admins and keeps the owner unchanged. Recursive ownership change. If you want to change the ownership of a directory and all its subdirectories and files recursively, you can use the R option. Bash. Sudo chown owner group /path/ to /directory. Replace owner, group, and /path/ to /directory with the appropriate values. Important notes. Ensure that you have the necessary permissions to change the ownership. You might need to use sudo depending on the current ownership and permissions. Be careful when using the recursive option R, especially on system-critical directories, to avoid unintended consequences. Always double-check the ownership and permissions after making changes to ensure they meet your requirements. Adjust the commands based on your specific needs and the user and group names in your system. Q28. I want to give sudo privileges to the same user through command? Answer. To give sudo privileges to a user in Linux, you typically add the user to the sudo group or modify the sudoers file. Here are two common methods. 1. Add user to the sudo group. You can add the user to the sudo group using the usermod command. This approach assumes that your system is configured to grant sudo privileges to users in the sudo group. Bash sudo usermod ag sudo username. Replace username with the actual username. After running this command, the user should have sudo privileges. The changes might take effect after the user logs out and logs back in. 2. Modify sudoers file. Another method is to edit the sudoers file directly using the vsudo command. Bash sudo vsudo. Add a line to the sudoers file to grant sudo privileges to the user. For example, text username all sadface all. Replace username with the actual username. This line allows the user to run any command as any user with sudo privileges. Adjust the privileges based on your specific requirements. Remember to use vsudo when editing the sudoers file to avoid syntax errors, as it performs syntax checking before saving changes. After making these changes, the user should be able to use the sudo command to execute commands with superuser privileges. Note: be cautious when granting sudo privileges, and only give the necessary permissions to users. Always follow the principle of least privilege. Q29. Let's say 3 branches A, B and master in Git now master. There is a conflict error, so how to resolve this error through your own? What both the code I want code into master branch, I want to push code or file. You can't push to master in your branch I want to push trying to merge because of conflict? How can I get file or code in my branch or push also getting file or code? Answer: resolving conflicts in Git involves merging changes from different branches that have diverged and addressing conflicts that arise when changes to the same lines of code conflict with each other. Here's a general guide on how to resolve conflicts when merging branches, particularly when working with the master branch. 1. Switch to your branch. First, switch to the branch where you want to merge the changes. Assuming you want to merge changes from branch A into the master branch. Bash git checkout master. 2. Merge the branch. Merge the changes from branch A into the master branch. Bash git merge a. 3. Resolve conflicts. If there are conflicts, Git will notify you. Open the conflicted files in your code editor. Git will mark the conflicting sections in the file. Manually resolve the conflicts by editing the file to keep the changes you want. 4. Mark as resolved. After resolving conflicts, mark the files as resolved. Bash git add conflicted file. 5. Complete the merge. Complete the merge process. Bash git merge continue. If you encounter issues with continue, you can use bash git commit merge branch A into master. 6. Push the changes. Finally, push the changes to the remote repository. Bash git push origin master. Important notes: always resolve conflicts carefully and ensure that the merged code functions as expected. If you're working in your local repository and encounter conflicts, you can use git status to see the conflicted files and the resolution progress. After resolving conflicts, it's essential to test the merged code to make sure everything works as expected. If you encounter difficulties resolving conflicts, consider using tools like Git Merge Tool or a visual Git client for assistance. Remember to replace branch names and master and file names with your actual branch and file names. The key is to resolve conflicts manually, mark them as resolved, commit the changes, and then complete the merge process. Q30. What is git fetch? What is check out which branch? Check out my branch or master branch? Answer. Git fetch. Git fetch is a Git command that downloads objects and references from a remote repository but does not automatically merge or modify your working directory. It's useful for fetching changes made by others without merging them into your local branches. Bash. Git fetch, remote, branch. Remote, the name of the remote repository, e.g., origin. Branch, the name of the branch to fetch. If not specified, it fetches all branches from the remote. For example, to fetch changes from the remote repository named origin. Bash. Git fetch origin. This command fetches the changes from the remote repository but does not automatically update your working directory or merge the changes into your local branches. Git checkout. Git checkout is a command used to switch branches or restore working tree files. It helps you navigate between branches and create new branches. In Git, you can use it to switch to a specific branch or commit. Bash. Git checkout, branch. Branch, the name of the branch you want to switch to. For example, to switch to a branch named myFeatureBranch. Bash. Git checkout myFeatureBranch. If you want to create and switch to a new branch, you can combine the creation and checkout in one command. Bash. Git checkout bNewBranch. Now, if you want to switch to the master branch. Bash. Git checkout master. Combining fetch and checkout. If you want to fetch changes from the remote and switch to a specific branch, you can use git fetch followed by git checkout. Bash. Git fetch origin. Git checkout myBranch. This fetches changes from the remote named origin and then switches to the myBranch branch. Remember to adapt these commands based on your repository structure and the branches you are working with. Q31. What are lists in Python? What are those? Answer. In Python, a list is a versatile and commonly used data structure that represents an ordered collection of elements. Lists are mutable, meaning that you can modify their contents by adding, removing, or modifying elements. Lists in Python are defined by enclosing a comma-separated sequence of elements within square brackets. Here are some key characteristics and operations related to Python lists. Creating lists. Python. Hashtag creating an empty list. Empty_list equals. Hashtag creating a list with elements. My_list equals 1, 2, 3, A, B, C. Accessing elements. Python. Hashtag accessing elements by index. First underscore element equals my_list, 0. second underscore element equals my underscore list, 1. Slicing. Python. Hashtag slicing to get a subset of elements. Subset equals my underscore list, 2:5, hashtag elements at index 2, 3, and 4. Modifying lists. Python. Hashtag modifying elements. My underscore list, 0, equals 10. Hashtag appending elements. My underscore list dot append, new underscore element. Hashtag extending with another list. Another underscore list equals 4, 5, 6. My underscore list dot extend, another underscore list. Hashtag inserting at a specific index. My underscore list dot insert, 2, inserted underscore element. Removing elements. Python. Hashtag removing by value. My underscore list dot remove, hashtag removing by index. Removed underscore element equals my underscore list dot pop, 3. List operations. Python. Hashtag length of the list. Length equals len, my underscore list. Hashtag concatenation. Combined underscore list equals my underscore list plus another underscore list. Hashtag repetition. Repeated underscore list equals my underscore list asterisk 2. Iterating over a list. Python. For element in my underscore list. Print element. List comprehensions. Python. Squared underscore numbers equals x asterisk asterisk 2 for x in range 5. Checking membership. Python. Hashtag checking if an element is in the list. Is underscore present equals b in my underscore list. Common list functions. Python. Hashtag sorting. My underscore list dot sort. Hashtag reversing. My underscore list dot reverse. Hashtag finding the index of an element. Index equals my underscore list dot index, b. Hashtag counting occurrences of an element. Count equals my underscore list dot count, Lists are incredibly flexible and widely used in Python for a variety of tasks due to their dynamic nature and rich set of built-in operations. They can store elements of different data types and provide a convenient way to work with collections of data. Q32. What is mutable? What are sets in Python? Answer. Mutable. In programming, mutable refers to the ability of an object to be changed or modified after it is created. If an object is mutable, its state or content can be altered, and these changes will be reflected in the object itself. In contrast, immutable objects cannot be modified once they are created. Examples of mutable objects in Python include lists, dictionaries, and sets. When you modify a list by adding or removing elements, the list is still the same object in memory. However, immutable objects like strings or tuples cannot be changed once they are created. Sets in Python. A set in Python is an unordered collection of unique elements. It is defined using curly braces and can contain elements of different data types. Sets are similar to lists or dictionaries, but they do not allow duplicate elements. If you try to add an element that already exists in the set, it won't be added again. Here's a simple example of a set. Python. Hashtag creating a set. My_set equals 1, 2, 3, 4, 5. Hashtag adding an element to the set. My_set.add 6. Hashtag trying to add a duplicate element won't raise an error, but the set won't change. My_set.add 2. Hashtag displaying the set. Print my_set. In this example, the set my_set contains the elements 1, 2, 3, 4, 5, and 6. When attempting to add the element 2 again, it doesn't change the set since sets only store unique elements. Sets are useful for various operations like testing membership, finding intersections, unions, and differences between sets. Q33. What are tuples in Python? Answer. In Python, a tuple is an ordered and immutable collection of elements. Tuples are similar to lists, but with a key difference. Once a tuple is created, it cannot be modified. This immutability makes tuples suitable for situations where you want to ensure that the data remains constant throughout the program execution. Tuples are defined using parentheses and can contain elements of different data types. Elements within a tuple are separated by commas. Here's a simple example. Python. Hashtag creating a tuple. My_tuple equals 1, 2, hello, 3.14. Hashtag accessing elements in a tuple. Print my_tuple 0, hashtag output 1. Print my_tuple 2, hashtag output hello. Hashtag attempting to modify a tuple will result in an error. Hashtag my_tuple 0 equals 10 hashtag this line will raise a type error. In the example above, my_tuple is a tuple that contains an integer, a float, and a string. You can access elements in a tuple using indexing, similar to lists. However, attempting to modify a tuple, as shown in the commented line, will result in a type error because tuples are immutable. Tuples are useful for situations where you want to represent a collection of values that shouldn't be changed during the course of the program. They are often used in scenarios where the order and immutability of elements are important, such as returning multiple values from a function or representing a pair of coordinates. Q34. Instana tool, Splunk tool? Answer. Instana. Instana is a performance monitoring and application observability tool designed for modern dynamic applications. It provides real-time insights into the performance and health of applications by collecting and analyzing data from various components of the application stack. Instana supports monitoring for a wide range of technologies, including microservices, containers, serverless architectures, and more. Key features of Instana include 1. Automatic discovery. Instana automatically discovers and monitors application components, dependencies, and services without manual configuration. 2. End-to-end visibility. It offers end-to-end visibility into applications, infrastructure, and services, helping identify bottlenecks and issues across the entire stack. 3. Tracing and profiling. Instana provides distributed tracing and code-level profiling, allowing developers to understand the flow of requests and identify performance bottlenecks in the code. 4. Dynamic baseline alerts. It uses machine learning to establish dynamic baselines for application performance and can trigger alerts when deviations occur. 5. Container and microservices monitoring. Instana is well suited for monitoring containerized environments and microservices architectures, providing insights into container orchestration platforms like Kubernetes. Splunk. Splunk is a powerful platform for searching, monitoring, and analyzing machine-generated data. It is commonly used for log management, security information and event management, (SIEM), and business analytics. Splunk ingests and indexes data from various sources, making it searchable and accessible for analysis. Key features of Splunk include: 1. Data ingestion. Splunk can ingest data from a variety of sources, including log files, databases, APIs, and more. It supports structured and unstructured data. 2. Search and analysis. Splunk's search functionality allows users to query and analyze large volumes of data. It supports a powerful query language and offers real-time search capabilities. 3. Visualization and reporting. Splunk provides tools for creating dashboards, visualizations, and reports to help users gain insights into their data. Users can customize dashboards to suit their specific needs. For alerting and monitoring, Splunk enables users to set up alerts based on specified conditions, helping organizations proactively monitor and respond to events or issues. 5. Security and compliance. Splunk is often used for security information and event management, (SIEM), to monitor and analyze security-related data. It can assist in identifying potential security threats and ensuring compliance with regulations. Both Instana and Splunk serve different purposes in the realm of monitoring and analysis. Instana is specifically focused on application performance monitoring and observability, while Splunk is a more general-purpose platform for analyzing and visualizing machine-generated data across various use cases, including IT operations, security, and business analytics. Q35. What is an AWS inspector? Answer. The primary goal is to assist users in identifying and addressing potential security issues before they can be exploited by attackers. Key features of AWS Inspector include: 1. Security assessments. AWS Inspector performs security assessments on AWS resources, including Amazon EC2 instances and applications running on them. It identifies vulnerabilities in the operating system, installed software, and configurations. 2. Agent-based. To perform security assessments, AWS Inspector uses an agent-based approach. Users need to install an AWS Inspector agent on the target EC2 instances. The agent collects data and sends it to AWS Inspector for analysis. 3. Rule packages. AWS Inspector uses predefined rule packages that include security best practices and common vulnerabilities and exposures (CVE) checks. These rule packages help identify potential security issues. 4. Custom rules. Users can create custom rules based on their specific security requirements. This allows organizations to tailor security assessments to meet their unique needs. 5. Integration with AWS security services. AWS Inspector can be integrated with other AWS security services such as AWS CloudWatch and AWS CloudTrail to provide a comprehensive security monitoring and response solution. 6. Scalability. AWS Inspector is designed to scale with the AWS infrastructure, making it suitable for both small and large environments. Q36. What is Artifactory? Why and where is it used? Answer. Artifactory is a universal binary repository manager developed by JFrog. It serves as a centralized hub for managing and storing binary artifacts such as software packages, libraries, dependencies, and build artifacts. Artifactory supports various package formats, including Maven, Docker, NPM, NuGet, PyPI, RubyGems, and more. It plays a crucial role in the software development and continuous integration/continuous delivery (CI/CD) processes. Here are key aspects of Artifactory and its usage. 1. Artifact storage. Artifactory provides a secure and scalable repository for storing binary artifacts. This includes JAR files, Docker images, NPM packages, Python wheels, and other types of artifacts produced during the software development lifecycle. 2. Dependency management. In a software development environment, projects often rely on external dependencies. Artifactory allows organizations to store, manage, and version control these dependencies, reducing the reliance on external repositories and ensuring consistency in builds. 3. Build promotion and distribution. Artifactory supports the promotion of artifacts through different environments, such as development, testing, and production. It facilitates the distribution of artifacts across teams and environments, ensuring that the same binary artifacts are used throughout the development pipeline. 4. Integration with CI/CD tools. Artifactory seamlessly integrates with popular CI/CD tools like Jenkins, GitLab CI/CD, and others. This integration allows for the automatic retrieval and deployment of artifacts during the build and deployment processes. 5. Security and access control. Artifactory provides robust security features, including access control, authentication, and authorization mechanisms. It allows organizations to define fine-grained permissions to control who can access or deploy artifacts. 6. Metadata management. Artifactory captures and manages metadata associated with artifacts. This includes information about dependencies, versions, and build information. This metadata can be valuable for tracking changes, debugging, and ensuring traceability. 7. Proxying external repositories. Artifactory can be configured to act as a proxy for external repositories. This helps in reducing the load on external repositories and provides faster access to frequently used artifacts by caching them locally. Artifactory is widely used in DevOps practices, enabling organizations to achieve better control, visibility, and traceability over their software artifacts. It enhances collaboration among development and operations teams and contributes to the overall efficiency and reliability of the software delivery pipeline. Q37. What about harness? Why is it used where it is used? Answer. Harness is a DevOps platform that provides a comprehensive set of tools for continuous delivery (CD) and release automation. It is designed to streamline and automate the software delivery process, allowing organizations to deliver applications more quickly, reliably, and efficiently. Key features and aspects of Harness include 1. Continuous delivery orchestration. Harness offers a visual and declarative approach to define and manage the entire continuous delivery pipeline. Users can create and manage pipelines that automate the steps involved in building, testing, and deploying applications. 2. Automation and scaling. Harness emphasizes automation throughout the software delivery lifecycle. It automates various tasks, including testing, deployment, and rollback processes. The platform is designed to scale with the needs of complex and dynamic environments. 3. Deployment strategies. Harness supports various deployment strategies, including canary releases, blue-green deployments, rolling deployments, and feature flagging. This flexibility allows teams to choose the deployment approach that best suits their application and business requirements. For infrastructure as code (IaaC) integration, Harness integrates with infrastructure as code tools such as Terraform and AWS CloudFormation, enabling users to manage and provision infrastructure alongside application deployments. 5. Continuous verification. Harness includes features for continuous verification, monitoring, and analytics. It provides insights into the health and performance of deployments, allowing teams to detect issues early in the process. 6. Collaboration and visibility. Harness aims to enhance collaboration between development and operations teams by providing visibility into the deployment pipeline. It includes features for audit logging, role-based access control, and collaboration tools. 7. Multi-cloud and multi-platform support. Harness supports deployments across various cloud providers, including AWS, Azure, and Google Cloud Platform (GCP). It also works with container orchestration platforms like Kubernetes. 8. Integration with CI/CD tools. Harness integrates with popular continuous integration (CI) tools such as Jenkins and GitLab CI, as well as source code repositories like GitHub and Bitbucket. Organizations use Harness to address challenges associated with manual and error-prone deployment processes. By automating and orchestrating the deployment pipeline, Harness helps teams achieve faster release cycles, reduce deployment errors, and improve overall software delivery efficiency. It's particularly beneficial in dynamic and complex environments where applications need to be deployed across multiple platforms and cloud providers. Teams adopting DevOps practices and aiming for faster, more reliable releases often find value in using Harness for their continuous delivery needs. Q38. What is a Helm? Why and where is it used? Answer. Helm is a package manager for Kubernetes applications. It simplifies the deployment and management of applications on Kubernetes clusters by providing a standardized way of defining, installing, and upgrading applications. Helm uses charts, which are packages of pre-configured Kubernetes resources, to define the structure and configuration of applications. Key aspects of Helm include 1. Charts. A Helm chart is a collection of pre-configured Kubernetes resources, such as deployments, services, and config maps, packaged together. Charts provide a standardized way to describe, install, and upgrade applications on Kubernetes. 2. Templates. Helm uses Go templates to allow parameterization and customization of Kubernetes resource files within charts. This enables users to create dynamic configurations and reuse charts with different values. 3. Releases. When you use Helm to install a chart, it creates a release, which is an instance of the chart deployed on a Kubernetes cluster. Releases can be versioned, upgraded, rolled back, and deleted. 4. Dependency management. Helm supports dependencies between charts, allowing you to define and manage complex application architectures with multiple components. Helm will automatically resolve and install chart dependencies. 5. Chart repository. Helm charts can be distributed and shared through chart repositories. Chart repositories are HTTP servers that serve an index.yaml file containing information about available charts. Public and private repositories can be used to share charts within organizations or with the community. Why Helm is used. 1. Simplifies deployment. Helm simplifies the deployment of complex applications on Kubernetes by encapsulating Kubernetes manifests and configurations into charts. This simplification makes it easier to manage and share applications. 2. Standardization. Helm provides a standardized way of packaging, distributing, and managing Kubernetes applications. This standardization helps ensure consistency across different deployments and environments. 3. Versioning and rollbacks. Helm allows you to version your releases and easily roll back to a previous version if an issue is detected. This helps in maintaining application reliability and facilitates safe experimentation with changes. 4. Configuration management. Helm enables the parameterization of Kubernetes manifests through values and templates. This makes it easy to customize configurations for different environments or specific use cases. 5. Community and ecosystem. Helm has a vibrant community and a rich ecosystem of publicly available charts. Users can leverage existing charts or share their own, promoting collaboration and reuse. Where Helm is used. Helm is widely used in the Kubernetes ecosystem, particularly in scenarios where complex applications or microservices are deployed on Kubernetes clusters. It is used in various contexts, including application deployment. Helm is commonly used to deploy and manage applications, including those with multiple interconnected services and components. Infrastructure as code. IAC Helm is often used as part of the infrastructure as code (IAC) practices for managing Kubernetes infrastructure and workloads. Continuous integration/continuous deployment (CI/CD) Helm charts can be integrated into CI/CD pipelines to automate the deployment of applications on Kubernetes clusters. Development and testing environments. Helm simplifies the setup of development and testing environments by providing a consistent way to deploy and manage applications. Overall, Helm plays a crucial role in simplifying and standardizing the process of managing Kubernetes applications, making it a valuable tool in Kubernetes-based container orchestration environments. Q39. I have an auto-scaling group. I want to scale up on the basis of memory utilization in auto-scaling group? Answer. Auto-scaling groups in AWS provide a way to automatically adjust the number of instances in a group based on specified conditions. Auto-scaling directly supports scaling based on Amazon EC2 instance metrics such as CPU utilization, network utilization, and disk I/O. Memory utilization, specifically, is not a direct metric that you can use out of the box for scaling decisions with auto-scaling groups. That said, you can implement a workaround to scale based on memory utilization by combining AWS services. Here's a general approach. 1. Use CloudWatch custom metrics. Use a monitoring solution or script to gather memory utilization metrics from your instances. Publish these custom metrics to Amazon CloudWatch. 2. Create a CloudWatch alarm. Create a CloudWatch alarm based on the custom metric for memory utilization. Define the alarm threshold and actions, e.g., scaling up, when the threshold is breached. 3. Auto-scaling policy. Create an auto-scaling policy that is triggered based on the CloudWatch alarm. Specify the scaling action, e.g., increase the desired capacity, when the alarm is in the alarm state. 4. Attach policy to auto-scaling group. Attach the auto-scaling policy to your auto-scaling group. This way, when the custom metric, memory utilization, breaches the defined threshold, the CloudWatch alarm will trigger the auto-scaling policy, leading to the scaling up of your auto-scaling group. Remember to consider the implications of scaling based on memory utilization. Scaling decisions should align with the application's requirements and performance characteristics. Additionally, regularly review and adjust the scaling policies based on the observed behavior of your applications. Q40. Let's say, I have 2 accounts in AWS, I have 2 IAM roles in that account, I have an S3 bucket in account A and another account B. I have EC2 instance. I want to access S3 bucket from account A through EC2 instance? Answer. To allow an EC2 instance in account B to access an S3 bucket in account A, you need to set up cross-account IAM roles and establish the necessary permissions. This involves creating an IAM role in account A that grants the necessary permissions for accessing the S3 bucket, and then configuring the EC2 instance in account B to assume that IAM role. Here are the general steps to achieve this. In account A. 1. Create an IAM role. Go to the IAM console in account A. Create a new IAM role that trusts account B. This involves specifying the AWS account ID of account B as a trusted entity. 2. Define permissions. Attach an IAM policy to the role that grants the necessary permissions on the S3 bucket in account A. For example, you might use the Amazon's free read-only access policy for read-only access. 3. Create an external ID, optional. Optionally, you can use an external ID for additional security. This is a unique identifier that is passed during the role assumption process. 4. Note down role ARN. Once the role is created, note down the ARN, Amazon resource name, of the IAM role. In account B. 1. Attach IAM role to EC2 instance. Stop the EC2 instance if running. Attach an IAM role to the EC2 instance in account B. This role allows it to assume the role in account A. 2. Define trust relationship. Edit the trust relationship of the IAM role attached to the EC2 instance to allow assuming the role in account A. This involves specifying the role ARN of the role in account A. 3. Configure AWS CLI or SDK. Install the AWS CLI on the EC2 instance or configure the SDK in your application. Use the assume role command or SDK method to assume the IAM role in account A from the EC2 instance. Now, when your application running on the EC2 instance tries to access the S3 bucket, it will assume the IAM role in account A, and if properly configured, it will have the necessary permissions to read or write to the S3 bucket. Remember to manage IAM roles and permissions carefully, and follow security best practices. Additionally, ensure that the appropriate trust relationships and policies are correctly configured to allow the cross-account access. Q41. What is DynamoDB? Answer. Amazon DynamoDB is a fully managed NoSQL database service provided by Amazon Web Services, AWS. It is designed to provide high performance and scalable storage with seamless scalability. DynamoDB is particularly well suited for applications that require low latency and high throughput access to data, and it is often used in scenarios where traditional relational databases may face challenges. Key features of Amazon DynamoDB include: 1. Fully managed. DynamoDB is a fully managed service, which means that AWS takes care of the operational aspects of database management, such as hardware provisioning, configuration, patching, and backups. This allows developers to focus on building applications without the need to manage the underlying infrastructure. 2. NoSQL database. DynamoDB is a NoSQL database, meaning it does not follow the traditional relational database model. Instead, it provides a flexible and schema-less data model, allowing developers to store and retrieve data without the need to define a fixed schema in advance. 3. Scalability. DynamoDB is designed to scale horizontally, providing seamless and automatic scaling of both read and write capacity based on the application's demands. This makes it well suited for applications with varying or unpredictable workloads. For high performance, DynamoDB is optimized for low latency access to data. It achieves this by using SSD storage for fast and consistent performance. It also supports in-memory caching with DynamoDB Accelerator, DAX, for further performance improvements. 5. Security and access control. DynamoDB provides robust security features, including encryption at rest and in transit, fine-grained access control using AWS Identity and Access Management, IAM, and integration with AWS Key Management Service, KMS, for key management. 6. Global tables. DynamoDB supports the creation of global tables, which allows for the automatic and seamless replication of data across multiple AWS regions. This enables global distribution of applications with low latency access to data. 7. Event-driven programming with streams. DynamoDB streams enable event-driven programming by capturing changes to the data in a DynamoDB table. This can be used for building applications with real-time data processing and analytics. 8. Integrated with AWS ecosystem. DynamoDB seamlessly integrates with other AWS services, including AWS Lambda, AWS CloudFormation, AWS CloudWatch, and AWS Identity and Access Management, IAM, making it part of a comprehensive cloud computing environment. DynamoDB is commonly used in a variety of applications, such as e-commerce platforms, mobile applications, gaming, IoT, Internet of Things, and more. Its ability to provide fast and scalable access to data, along with its ease of use and management, makes it a popular choice for developers building applications on the AWS cloud. Q42. I have DynamoDB and I have a script I want to push elements from DynamoDB to S3 bucket. In DynamoDB, what is export? Answer. DynamoDB exports to S3, understanding the mechanism. There are two key concepts to understand when it comes to pushing elements from DynamoDB to an S3 bucket. 1. DynamoDB streams. DynamoDB streams automatically capture a continuous stream of changes made to your DynamoDB tables. These changes include insertions, modifications, and deletions. The stream data is stored in Kinesis data streams, which offer a highly scalable and durable way to process data in real time. 2. DynamoDB exports. DynamoDB exports allow you to export a snapshot of your table data at a specific point in time to an Amazon S3 bucket. This exported data is stored in JSON format and can be used for various purposes, such as backup and disaster recovery. You can export your table data regularly to S3 as a backup, ensuring you have a reliable copy in case of any issues with your DynamoDB table. Offline analysis. You can analyze your DynamoDB data offline in tools like BigQuery or Redshift by exporting it to S3. Data migration. You can migrate your DynamoDB data to another data store by exporting it to S3. So, in essence, DynamoDB streams offer a way to push real-time change data to S3. This is ideal for scenarios where you need to react to changes in your DynamoDB table immediately. DynamoDB exports offer a way to export a snapshot of your table data at a specific point in time to S3. This is ideal for scenarios where you need to have a copy of your data for backup or analysis purposes. Additionally, your script likely interacts with DynamoDB streams to capture change data and push it to S3. There are various libraries and tools available in different programming languages for interacting with DynamoDB streams. If your script requires a one-time export of a static snapshot of your data, you can use the DynamoDB console or AWS CLI to trigger an export job. I hope this explanation clarifies the difference between DynamoDB streams and exports in the context of pushing data to S3. Q43. I have an EC2 instance and the root volume gets full. I want to attach a new volume without any downtime on production. At that same time I have a request comes to EC2 application. Answer. Attaching a new volume to your EC2 instance in production without downtime while handling incoming requests requires careful planning and execution. Here's a step-by-step approach. Preparation. 1. Choose the new volume type. Select a volume type with appropriate throughput and performance to handle your application's workload. Consider SSD volumes for frequent read/write operations. 2. Create the new volume. Attach the new volume to your EC2 instance. Choose the appropriate device name where you want to mount the new volume. 3. You format and mount the new volume. Inside your EC2 instance, format the new volume, e.g., mkfs.ext4/dev/xpdf. Then, create a mount point, e.g., /new volume, and mount the volume, e.g., mount/dev/xpdf/new volume. 4. Move data to the new volume. This depends on your application and data structure. Consider options like RSANSI, tar, or application-specific tools to move data from the root volume to the new volume. Alternatively, you can configure your application to write directly to the new volume. Minimizing downtime. 1. Use tools like RSANC or tar with options for incremental transfers. This minimizes copying already transferred data and reduces downtime. 2. Consider using a load balancer. Distribute incoming requests across multiple instances if available. This ensures some instances can focus on data migration while others handle active requests. 3. Implement rolling updates or canary deployments. If your application allows for phased updates, gradually migrate data to the new volume on a subset of instances, canary, before rolling out to the entire production environment. Additional tips. Pre-test the data migration process in a non-production environment. This helps identify and address any potential issues before impacting production. Monitor your application and resource utilization closely during the migration process. Ensure everything runs smoothly and adjust resources if needed. Have a rollback plan ready. Be prepared to revert to the original setup if you encounter unexpected problems during the migration. Remember, every application and environment is unique. Adapt these steps and tools to your specific scenario. Ensure you're comfortable with the chosen approach and test it thoroughly before implementing it in production. Q44. I have a Lambda function which is in VPCA and I have a S3 bucket in VPCB. I want to access the S3 bucket through Lambda function? Have you heard about VPC endpoints? Answer. Yes, I've definitely heard of VPC endpoints. They're a great way to securely access AWS resources like S3 buckets from within a VPC without needing internet access or public IPs. In your case, where your Lambda function resides in VPCA and the S3 bucket is in VPCB, VPC endpoints are indeed the recommended approach. Here's a breakdown of how you can achieve this. 1. Create a VPC endpoint for S3 in VPCA. Go to the VPC service in your AWS console and choose Endpoints. Click Create Endpoint and select Service Gateway as the type. Choose Amazon S3 as the service and select VPCA as the VPC. Optionally, you can choose full access or configure a custom VPC endpoint policy to restrict access to specific S3 buckets or operations. 2. Update your Lambda functions security group. Add inbound rules to your Lambda functions security group allowing traffic from the VPC endpoint created in Step 1. You can restrict the rule to the specific port used by S3, 443, and the IP ranges of the VPC endpoint service for further security. 3. Configure your Lambda function to access the S3 bucket. Use the AWS SDK for your programming language and configure it to use the private hosted zone name of the VPC endpoint instead of the public S3 endpoint URL. This ensures your Lambda function accesses the S3 bucket through the secure VPC endpoint within your network. Benefits of using VPC endpoints. Enhanced security eliminates the need for public internet access and increases network isolation. Improved performance. Direct communication within the VPC can lead to faster data transfer speeds. Reduced cost. No charges for outbound internet traffic through the VPC endpoint. Remember, you'll need sufficient IAM permissions for your Lambda function to perform operations on the S3 bucket. Additionally, ensure your VPC configurations allow communication between the two VPCs for the VPC endpoint to function properly. Q45. Have you worked on EKS? Answer. Creating an EKS cluster. There are three main ways to create an EKS cluster. AWS Management Console, the easiest option for beginners, although less customizable. Navigate to the EKS service and click Create Cluster. Follow the wizard, selecting desired options like instance types, networking configuration, and IAM roles. AWS CLI, more flexible and efficient for automation. Requires familiarity with AWS CLI commands. Use the extl create cluster command with specific parameters for your desired configuration. Extl, an open-source command line tool specifically for managing EKS clusters, offers higher flexibility and automation than the AWS CLI. Download and install extl, then use the create cluster command with desired parameters. Why is EKS used? EKS offers several advantages over managing Kubernetes clusters yourself. Managed Kubernetes Service, AWS handles underlying infrastructure and maintenance, allowing you to focus on applications. Scalability and elasticity, easily scale your cluster up or down based on workload demands. High availability, automatic cluster recovery and replacement of unhealthy nodes. Security and IAM integration, seamless integration with AWS security features and IAM for access control. Cost effectiveness, pay only for the resources you use. Where can EKS be created? EKS clusters are created within your VPC, Virtual Private Cloud, on AWS. Your VPC defines the isolated network environment for your resources. You can have multiple EKS clusters in a single VPC or even across multiple VPCs for specific needs. Steps and configuration. The specific steps and configuration for creating and configuring an EKS cluster depend on your chosen method and desired settings. Here's a general overview. 1. Define your cluster configuration, choose instance types, network settings, IAM roles, security groups, etc. 2. Create the VPC and subnets, if not already existing. Create a VPC with isolated subnets for your cluster nodes and pods. 3. Create the EKS cluster. Using your chosen method, console, CLI, extl, run the command /wizard with your defined configuration. For verify cluster creation, access the created cluster details in the console or through kubectl commands. 5. Configure kubectl. Download and configure kubectl for local access to your EKS cluster. 6. Configure additional settings, optional setup logging, monitoring, metrics, and other desired tools. Remember, this is a basic overview. Each step can have various options and settings depending on your specific needs. It's important to consult the official AWS documentation and explore resources like extl documentation to ensure you configure your EKS cluster precisely for your intended usage. Q46. What is your current designation in your organization? If you are okay with this position, CloudOps will be solved here. Are you ready to work? Answer. Here's how I would respond to those questions in an interview setting. 1. My current designation. My current designation is a large language model at Google AI. I'm still under development, but I'm constantly learning and improving my abilities in various areas, including CloudOps. 2. CloudOps and readiness to work. While I am capable of assisting with many CloudOps tasks, I am still under development and may not be able to handle all aspects of the role independently. However, I am constantly learning and improving, and I am confident that I can be a valuable asset to your team in several ways. For example, I can help you automate tasks, analyze data, and generate reports. I am also eager to learn more about your specific needs and how I can best support you. So, while I wouldn't consider myself a complete solution for CloudOps at this stage, I am definitely ready to work hard and contribute to your projects in any way I can. Additional tips. Express enthusiasm and a willingness to learn. Showcase your eagerness to contribute and grow within the role. Highlight your specific skills and capabilities relevant to CloudOps. Mention any prior experience or training you may have in relevant areas. Be transparent about your limitations as a language model. While confident in your abilities, acknowledge that you're still under development and emphasize your willingness to learn and collaborate. Focus on the value you can bring to the team. Instead of dwelling on limitations, emphasize how your unique skills and abilities can benefit the team and contribute to solving CloudOps challenges. By responding in this way, you demonstrate self-awareness, a growth mindset, and a strong desire to contribute to the team. This approach can make a positive impression in an interview setting and showcase your potential as a valuable asset, even while still under development. HR email: sania.modi@volanzis.com